Hello, everyone. So it's time for another community meeting. So we'll wait for maybe 30 seconds, as I know Lisa will join us. She's one of our community engagement girl. Okay, I will start first. So today's this is the agenda today. Maybe we can introduce the new coming girls later, which is Lisa, spoiled. So we will go with the project heartbeat first. Before we start, as usual, I will give a brief introduction of the community meeting. We will have it bi-weekly, and every time before a meeting, everyone can propose a topic to be shared or to be discussed, to be requested. And feel free to reach out to us from the Slack channel or via the documentation, which is Etherpad online. Anyone can add it. And after a meeting, we will share the whole record in a video and text, and it will be archived in YouTube and our GitHub wiki. So during the meeting, we will have the project heartbeats, the ad hoc topics. Anyone can bring us. You can put your RFC, your idea, your I made this stories here, and we will have an open discussion. Okay. Welcome, Lisa. So I will have you being introduced later after I give this brief introduction. And we will have open floors for any questions or discussions, and you can propose it before I will mute you first, Lisa, before every meeting. And we will try our best to arrange anyone that you would like to discuss with. And today I will give an ad hoc topic as well, as usual. So the first topic is the heartbeats of the projects as usual. And the first one are the issues. So we have two interesting issues, and they are it's still under discussion, and the implementation is not yet started. And they are all related to the optimization of the Nebula Graph Core. So one is to use the multi-get interface of the RocksDB instead of the the single get. And the other one is to refactor the thread pool of the storage side to ideally improve the performance. They have very good discussions there, so be sure to check out there if you are interested. And regarding hi Lisa, I saw your turn. Maybe I can put it here. Yeah. So Lisa is in our new office of the VSoft. I will introduce you later. Then we come to the latest merged PRs. The first one is related to our meta daemon. So this PR is already merged, introduced a global lock, and previously we are using segment lock in different places. And for the reason that the write traffic for meta isn't that heavy as it was before, or as was we thought it was. And our designers decided to use a global log instead, and let's see how it goes in the coming months. This PR is fixing an issue that previously we don't have a precise permission control on queuing queries, and this one improved that. And this is a new flag default value. It's related to when you removed a space, and underlying the data will not be deleted physically, but instead it will be marked deleted. So this behavior is related to whether during a restart it will be deleted during the booting up, or it was done waiting to next compaction. So by default now it's in true now, before it was false. So this is the last one is in the core part is related to the get property supports on the limb pushdown. So and now it's implemented, it's done, and it's a subtask of the whole pushdown works. Please check out this issue, and you will have the whole picture of the progress. So on the other side, one big thing is we have the ARM build capability ready again. Previously it was added, but it was removed during our third-party changing, and now it's added back. I know everyone using a M1 MacBook Pro is eager for this feature. It's back, and actually from last week, our neatly built Docker image is supporting both x86 and the ARM architecture, so you can enjoy it from your ARM-based MacBook or Raspberry Pi. Another thing, another merge is related to our Kubernetes operator, and now we fixed the configuration capability to support Helm auth. And the last one is related to our Nebula community contribution org. And this is a new repo donated by our community member that they were doing a fantastic job based on the Euler. Euler is the open source job project on the deep learning platform. So they replacing their in-house graph database storage layer of this project and use the Nebula Graph. So check out this repo if you are interested. And we have the related posts, blog posts posted maybe in Chinese for now only, but in near future there will be an English version. So check out that. So we have done our project heartbeats part. So maybe we can introduce new members. Lisa. Hi, Lisa.
Hi, Wei.
Yep.
Nice to meet you here.
And
very nice, very happy to see you in this channel. I'm the new member in the Nebula Graph community. Now I'm the operating specialist and responsible for our community health.
Yep.
And maybe talking with our users. And in this meeting, I expect to meet more and more members from our community, so we can have a very happy discussion about our products and our community, like that things. Okay, that's all.
Fantastic. Thank you, Lisa. So Lisa is a quite kind-hearted girl, and being everywhere in our community like Slack or forum or GitHub or Twitter. You can find her also in LinkedIn, so or Instagram. So thank you, Lisa. And
thank you, Wei.
Yeah, so we'll move forward. Yep, so I will start the ad hoc topic today. So I will give some sharing on how to contribute Nebula Graph Core and how to build it in a smooth and easy way, and how you can debug it. And later, this is also the outcome of this topic will be also shared in our documentation for developers. So yeah, I will start. So I will start with the architecture of Nebula Graph Core. So I think you may be familiar with it already. There are three types of binaries or services of Nebula Graph. So they are graph service, meta service and storage service. So the graph service is our NGQL traffic interface, and it's the only interface exposed to end user or NGQL clients. So if we are talking with Nebula Graph only with the query, so only the graph service should be connected to. And underlying there are other two services, which is the meta service, then the storage service. So for meta service, the metadata are including the authentication, authorization, and the sharding information of all the storage layer, the service discovery of the graph D and the storage D, and how the graph spaces are isolated and distributed in among the all the storage instances, the schema information, and it's also maintaining the long run jobs, the life cycle of the jobs, and like other information like the data TTL, etc., etc. So they are all maintained in the meta D. And if you are implementing them in the multiple replica mode, like 3, and it's actually in an active standby mode. So only one of them, which is the leader in the raft consensus, is accessible. And yes, so they are synced in raft protocol. And underlying, like for example, when you are making a login, the graph D will talking to meta D for us. So end user won't need to talk to meta D in case you are only using an NGQL query. And storage D is the one behind that to serving the storage layer. And it's a distributed storage. So the data will be sharded in a static hash way. So it's not using, it's not using a ring, and it's also consensus with the raft protocol. And so per each shard, if you choose to have multiple replica, so underlying is also the raft. And underlying in the local layer, it's actually leveraging the RuxDB as a local storage engine, and it's exposing some like get neighbors, get properties interface to the graph D. Graph D will call the neighbors of properties. It's already a graph term of the interface. And underlying is the KV storage in RuxDB. And then, as I mentioned, reviewed something on the communication. So they are communicated in different ways. And by default, all the service will expose a thrift serving as a thrift server. So they are by default listen on different pods here. So for example, if we are using Nebula Console, which is a command line NGQL query client, it's underlying a thrift client talking to the graph service implemented in Go. And so graph D will actually call the meta D for different purposes. As I mentioned before, for example, if you are doing a login here, it will make the thrift call with a meta client to the so here in this collect, the meta client is a thrift client to the thrift server in the meta D. And also for the service discovery, as I mentioned before, all the services, all the graph and the storage services will report their notify the meta D services that I'm a newcomer, so you can register me as a new service. So it's also done through this thrift service, thrift interface. And For example, when we have a query like a match n, return n, limit 100, we have an NGQL query to graph D. So graph D will first talk to the meta to get the related information like related spaces and how the data was distributed and where can we get the data for storage. So what are those storage D instances? So it will talk to the meta D first, then it will talk to the storage D, just like here. It will also talk the storage. So when the graph D is calling the storage D, it's leveraging the storage client. So underlying it's a Thrift client talking to the Thrift server served by the storage service. And also storage D will do the service discovery thing similar to graph D talking to the meta D, and the storage D will have the raft traffic between or among all the storage D instances. So this is the brief view of the communications underlying. So for example, there are actual HTTP interface per each type of service. You can do some admin or statistic purposes on that interface as well, but that's not the main communication traffics. So for details, you can check out more documentation, the configuration, and our code base. And the architecture, more architecture information can be reached out from this documentation chapter here. Yeah, for further, actually, we have a couple of blog documentation, blog posts in our blog here. So they are tagged in a very quite easy way. Like you have tag of architecture, you have tag of source code, and tag of feature introduction. So this is the source code explained series of the blog posts. So you will have more information related to how it was designed and how the dots were connected. Yeah, so feel free to check those posts if you are interested. And then we will move on. So next topic is on how we can develop. We can make some changes or debug the Nebula Graph, the core database. So this is I consider the easiest way to make everything prepared, ready, and clean way. Yeah. So I will. So we will start with the clone of the repository, and here we are assuming we are working on the 3.0.0 tag, and then here is we need to create a developing container. So the good side of this approach is you will have every third party ever developing util ready out of box in this Docker image. So in this Docker image, and the second one on the other hand is you won't make your operating system dirty during preparing everything here. And the other thing is you can make isolated environments in parallel if you are doing on different versions development, or if you are working on other C++ projects, so it won't make your environment dirty. So, and before I initiate this Docker container, I actually create a Docker network. So this will be handy for us to make this. So it's a distributed system. You can debug on one of the binary, and you can still make it talking to existing cluster, and that's running on Docker. And our Nebula Graph Compose project is handy for this. And by default, is creating a isolated Docker network. So with this step, you can talk to all the other meta and the storage in the easiest way. So be sure to do this. I will share this in our development documentation later. And then you just every time you want to access this long run container, you can stop it anytime. You just stop it. So the name here, I use the Nebula underscore with your username, so you can rename it as you prefer, and then you can access it in this way. So after this we can build it without dealing with any dependencies or utilities of the the C++ and the dependencies. And every time the first time you will need to build the source code without any changes. So afterwards you can the build will be much more fast, much faster, because you will only rebuild the delta part that you changed. So this is the long configurations of the CMake. So for example, I might make the testing off because we want to build it for the first time. We don't change anything. We don't need to verify the unit testing for the existing code base. We can enable the debug because we want to use the GDB later to see how the code was going through inside the code base, and you can make in different numbers according to your CPU number, and then you making store, you will have all the built binaries and the built configurations and other files in one place here. So you will have all this here. So we will leverage those files later when we are moving on debug part. So then we will start the debugging of Nebula Graph. So in this example, I'm showing you how we just debug the graph D part. So, but it will be similar if you want to debug the meta or storage part. So so I'm assuming that we will set up a cluster with the Docker Compose rather than start all the needed binaries yourself. So here I check out the Compose file from the GitHub, and I'm be sure to use the same tag of your build code, right? If you are using V3, so you be sure to use V3 as well, and make it up. And after it's up, so in V3, be sure to connect it with the console like this, and then be sure to add all the storage service. This is to activate all the storage instances. So this is a behavior change in V3. You can check before and after on the show host. Before it will be offline, afterwards it will be shown online. And then you can use in the same console session, you can use the play basketball player. It will help you to load the basketball player data set for you, so you can tweak NGQL query and debug it further. And afterwards, you can exit it. Sorry. And after we have a cluster, and now we can add our debug, our new standalone GraphD instance joining to this cluster, and then we'll connect to this this debugged version of GraphD, and we will make breakpoint on this session, on this process, and we can do or check the variables and how it goes in the code base. So first we access the development container we created in the previous steps, and we can start this binary with GDB, which is standing for the GNU debugger, which is handy for the C and C++ debugging. And before we start running the process, we need to set some flags because it will fork different process. So we should use a fork mode child, so we can be ensured to jump to the corresponding child. And then we set the arguments. So this is actually related to configuration of this instance of the NebulaGraph GraphD. So we are configuring our local IP with our dev container name. So in Docker, your container name will also be treated as a domain name. So just like we are talking to the meta D0 with this name, so this is the equivalent address of our GraphD in a debug mode. So assuming my user here is named Tom, so be sure to replace this part to your username accordingly. So then we will have everything set up on the GDB, and then we can set a breakpoint. So I use B, and this is the function name of where you want it to stop, and you will check from there. So here I just gave an example of this function name. And after this, you can hit run. It will set up the process for you. And after a while, you can, after you be sure to run the run, the service will be up. So you can now run your console again to connect to here, to connect to your debug GraphD instance. So here is the address. Assuming we named it Tom. So then we will connect to the GraphD debug GraphD, and you can see if it's booting up properly. The service itself will be registered to the meta. So after you are using show graph host graph, you will see our debug instance here in the same version. So they should be in same version, or you will have some unexpected behaviors. And then you will make a query here. So here I'm making a query with the IDs at vertex ID at the starting point. So it will be stopped. Remember, I put a breakpoint here. It's related to this VID extract visitor. It will be hanging there, and you can continue your debugging from here. So you will see something here like this in your GDB command line session, and you can leveraging all the powerful tools in the GDB. So here I'm just demonstrating the most trivial ones. For example, if you hit F enter, you will see where you are. So this is the exact function. Remember, I use the B space of this function name. So you will be stopped here in the this file in line of this line, and then you can list the surrounding lines with L. You can see this is our function here, and this is the related lines, and then you can use the print space with the variable of current scope. Here we can see this variable here, so you can print it. So this is very handy, right? And you can use the BT, which stands for the back trees, and here we can see all the back trees from this line. There are more of them. I all made them here, and you can choose with next, which is the N command, to continue to next line. Also, if you are reaching like to a for loop or a while if, or calling another function line, so you can use S enter to enter that deep layer of that call. Instead, if you are using N, it will execute that line and to the next line afterwards. So this is a step in command, and you can, or if you have everything you needed, you can use continue to move on. It will not stop until another breakpoint. So this is basically all the trivial, the most frequent used commands of the GDB. So with all above information I shared, so ideally you will have a handy environment and the workflow on how you want to debug the graph database. And if after your debugging with this flow, you will know where you want to change a bit, and you will, after you change everything, you can rebuild the code just like this. But in this time, you can either enable the testing to just select the unit test to help you know, regression your change, or you turn it off with this debug. You can continue this process, continue of the GDB process to debug your changed graph version of the GraphD continually. So after that, you will have a handy environment and workflow on how to contribute and debug Nebula Graph. So that's all from this topic. So we don't have newcomers, so we will move on. Yes, and before we call this end, be sure that we are having this meeting bi-weekly, and be sure to register our meeting in Zoom, and we have a Google Calendar. You will have it reminded in your Gmail, and put your topics on this Etherpad. So all this information are in our wiki page. And two things to be highlighted before we end it. The first one is the Nebula Graph Cloud on Azure is open beta. So be sure to check out on Azure Cloud. You can search Graph Database, so you will see Nebula Graph Cloud in the marketplace here. And the next thing is we just celebrated our 2022 International Women's Day, and this is a great tweet posted by Lisa. So be sure to check out. So this I really enjoy this this artwork, so by our designers in community. So it's Ada Lawless, which is a very initial coders in the world. So she's a very cool girl. Happy Women's Day. And I think we can call this a day. Lisa, any question or any information to be added?
Actually, no.
Okay.
Yeah,
thank you.
This meeting is amazing.
Yeah, thank you. Thank you so much for joining us. So I will call this an end. So see you 2 weeks later, and be sure to reach out to us in Slack, GitHub discussions or forum.